Hi, Leo Drager here. I want to talk to you about writing a basic C program, compiling it, and executing it. We're going to take a very simple approach. We're just going to do a simple, print statement. But I want to kind of take some of the mystery about how to write a basic C program. So if you're fluent with C programming, you may want to skip this video or just continue watching it for accuracy. But basically what we're going to do is we're going to go to our desktop inside of our Kali Linux image. We're going to right click, select new document, and just select a new empty document. And you can call this whatever you want. Typically it would be the name of your program. So we'll do Cybrary.c is the name of the program. And you can see it changes it to the icon's a little bit different. If we were to change it to something and rename it to something like, TST, it'll change the file extension. But we can go ahead and leave it as a .c. But this is, again, uncompiled code at this point. So go ahead and open the file up. You can double click it or edit the file, or open with any basically editor that you need will be fine. Okay, so the first thing that you want to do is basically include some of the header file information. And to do that, let me get out of my, let's do that again. Okay, there you go. All right, there we go. All right. So what we're going to do is basically include some of the header information. Now these are good to have because they basically tell the C code exactly where to start and what to reference, and it really depends on what compiler you're using. But nonetheless, this is just good practice to have in any sort of programming. So the pound signs are going to be comments. These are actually get stripped out when you actually compile your code. Or should anyway, but again, it probably depends on the compiler. So we're going to go ahead and do a pound statement, which is a comment, and we're going to include with a bracket a standard input and output .header file, and we basically just do an stdio .h and then include that with a less sign and then a greater sign. Style brackets, not to be confused with some of the other brackets that are available, but nonetheless these are the header files. These are also part of the preprocessors which are used when you actually compile your code. So the common ones that you really want to start getting a practice for would be the standard input and output, and then the standard libraries. So go ahead and start with two comments, include stdlib.h. Now there's a little bit of a variance if you're going to use single quotes or less than and greater than signs, and it just depends if things are already in your path or already not in your path. We're not going to cover that here, but just wanted to make a quick reference of it. So it's basically standard input and output, standard library header files. Then we can go into just writing some basic code. So we can do initialization main, and then go ahead and do two brackets, and notice they highlight here start and stop. That's helpful to reference to make sure you don't have an extra bracket somewhere. So then we're gonna add in another bracket, and then we're gonna do a print statement. So we're gonna do a printf, open the bracket, and we're gonna do Cybrary.it is cool, \n, quotes, and then go ahead and end that. And then you notice they highlight the start and the stop. That's helped to make sure that, again, you're consistent. And then go ahead and add a semicolon to the end of that, and then hit enter. Do a return. Okay, 0, start and stop bracket, semicolon, and then go ahead and finish the statement, which notice they get highlighted as well here and here. And that's the basic code. I mean, this is about as basic as it's going to get. Because all we're doing is basically going to compile this code. When we execute it, it's going to print the statement to the terminal, cyberarray.it is cool, and then go. So pretty basic, pretty straightforward. All right, so go ahead and then click File and then Save. All right, and then open up a terminal. And if you do a print working directory, you'll see that I'm under root. So we want to change directory to desktop. So that way we can actually see that our source code or our cyberarray.c is actually available. And then we're going to go and get an installer. Now, Kali Linux has the GCC compiler already located in it, and you could prove this by doing a locate GCC, right? If you get a whole bunch of stuff back like I did, clearly you have something, or else it'll say, not found. That means you don't have it. So I'm going to scroll back up and try to make some sense out of this for you. So here we go. So locate GCC. Okay, so the first thing we see here is basically some opt firmware, and we can go ahead and skip these, but you see things like makefile.gcc and things like that. We're going to scroll down. User bin. There's lots of GCC in the bin directory or the binary directory. We have lots of library support, so that's a good sign as well. Again, you wouldn't see any of this if GC was not installed on your system, no matter what Unix system that you would be using. So, and then of course a whole bunch of depackage information, which is where a lot of the libraries are kept, and you can see the var library. So nonetheless, what I'm proving here is that GCC is installed. Now, if I clear the screen and I wanted to actually install this, we could do a sudo apt get install build-essentials. All right, and I'm going to do this without the sudo command because I'm already logged in as root, and I'm going to spell it correctly. Build essential, and I'm going to spell install correctly. And you can see that it'll go out, it'll look for it, and it's a build-essential is already the newest version. This is another way that you could check. But if it wasn't, then by typing this command apt-get install build-essential, that would install the necessarily compilers necessary. So if you're not on this particular Unix or Linux build, you could certainly add it to your system relatively easily. Install is painless, takes 5 seconds, so you can go ahead and run that. So we'll clear the screen. Now let's go into compiling our sample program. So if I list what's in here, you can see that I have a cyberarray.c. So we're going to do a GCC. We're going to do the name of our source code. So it's cyberarray.c. And then our output, which is whatever the name of the executable that you want this to be named. So we'll just do it. We'll be simple and cheesy here. We'll call it cyberarray. And enter. Now, if you don't get any errors, things went pretty well. So that's it. We have just written some code. We have just compiled some code. Pretty simple. Next part, we get to actually run the code. Right? So do a / dot / and then the name of your program and hit enter. So cyberarray.it is cool, which is the print statement that we had in our document. And that is the absolute basics to, one, getting some C code in a file. Again, very, very simple. And you can build upon this, right? Next, you can start putting in memory allocation and start setting parameters or start manipulating this file and building upon it, which we'll do in subsequent videos to try to get it to do something cool other than, printing something to the terminal. So what we've done is written some C code. compiled it, and then executed it. And you can see it was relatively easy to do. So a little knowledge on C programming, you can certainly easily just create some generic code. Now, in the next couple videos, we'll start looking at input statements and memory allocations and things like that, and start looking about how we can basically make this program do bad stuff. So that's it. My name is Leo Drager. Thank you for watching. And don't forget to check us out on Facebook, LinkedIn, YouTube, and Twitter.